So we're looking at quadratic inequalities, and we're going to look at this in more of a graphical view. We just finished graphing quadratics. Later on, the next chapter, we'll look at quadratics where we're testing point, or not just quadratic inequalities, but polynomial inequalities where we're testing points and finding out what is a true or false and the solutions to that inequality. So for instance, let's look at this and let's look at a graphical picture of an inequality, or not an inequality, of a quadratic equation. So maybe we have a parabola and it's facing up. We have a point at -3, 0. Point at 3, 0. And it looks something like that. I don't like how. Let me just change this piece. If they, and let's say this is f of x, and they want to know when, find when f of x is greater than 0. Okay, well, this is saying basically, we're looking at our graph. This is our y value, right? So when is the y value positive? So if we look at this, right, it's going to be positive when it's falling above the x-axis. And so what we're trying to find are the x values where this is bigger than 0. So we're going to find the x values. Where this is true. So notice it's the x values where we're from -3 and going towards -infinity, and +3 and going towards +infinity. We're not including those two points where it's intersecting the x-axis because of the greater than sign. So our solution is everything from -infinity all the way up to -3. When we don't include that in value, remember we put the parentheses, union, and then parentheses because we're not including 3, then 3, infinity. So they might ask you to graph the solution set on the number line. We pretty much did that up here when I looked at the graph, just on the x-axis. So we're looking at all x values to the left of -3 and all x values bigger than 3, or to the right. So if you're okay with knowing how to graph these inequalities, really technically a couple things we need to know. We need to know what our x-intercepts are, and we need to know what way it's facing. So in this case, if this is g of x, and they want to know when is g of x less than or equal to 0, well, this is always above the x-axis, right? And so there's no y values which give us a negative number. And so this is never, there's no solution. The graph is always above the x-axis. Where if they had said, where is this less than or equal to 0, either one. I'm sorry, I already did the less than, greater than or equal to. So this is where all x values are going to satisfy our y values being positive. So we're looking from negative infinity to infinity. So it says solve the inequality. And we have x squared minus x plus 1 is less than or equal to 0. Okay, so first thing that we want to do in this section is we want to graph, or we want to first get everything to one side of the inequality, which it is, and then we want to graph this. So we want to graph y equals x squared minus x plus 1. Okay, so last week when we were looking at this, there's a couple things that we need to know. We need to know where the vertex is, and we can put this in vertex form, or we could use that vertex formula. So let's just use that vertex formula. The vertex formula said our h value, our vertex is at hk. And we can find h by looking at what negative b over 2a was. And then we could find k by going back in and plugging that in wherever we see it, x, in our function. So h in our case, negative b, so this is our b value. The negative of negative 1 is just 1, all over 2 times a, and our a value in this case is 1. So h is equal to 1/2. And then k, we want to go back in, and wherever we see an x in their function, we're going to plug in this 1/2. So we get y is equal to 1/2 squared minus 1/2 plus 1. I probably should have done that green. So y is equal to 1/2 squared. 1/2 times 1/2 is 1/4 minus 1/2. If you don't mind, I know I'm going to need a common denominator, so let me multiply that by 2 over 2 plus 1, but 1 we can rewrite as 4 over 4. So we get y is equal to 1/4 minus 2/4. So that's a negative 1/4, and negative 1/4 plus 4/4 is 3/4. Let me just say that is just k. Okay, so we just found our vertex. One half, comma, 3/4. Our value of a, remember a, if a was bigger than 0, the parabola faced upwards. And if a was less than 0, that coefficient was a negative number, it faced downwards. So our a value in our case is bigger than 0, so we're going to face upwards. And we know where our vertex is. So at 1/2, 3/4. And again, we said it was facing upwards. So I'm just going to go like this for now. So remember, we talked about how if we could find our vertex and know the direction, then that could save us some work in order to, do we need to find out where this is crossing the x-axis or not? Well, I know I'm not going to find an x-intercept if it's facing upwards and it's above the x-axis. And so when it said solve this inequality now, where our x squared minus x plus 1 is less than or equal to 0, well, again, this is looking at when is my y values below the x-axis or equal to 0. And in this case, our graph shows that it's never going to be. So in this case, there's no solution. Okay, so you're just using the tools that you found from graphing last week and then figuring out. Let's look at one more. So 2 all times 2x squared minus 3x is greater than negative 9. So this is not in the form that I know how to graph this. Remember, we have to get in the form of ax squared plus bx plus c. So I have to get everything to one side of this inequality and then either put it into that vertex form so I can tell what the vertex is, or use that vertex formula. So distributing my 2, we get 4x squared minus 6x. And then I'm going to add 9 to both sides to get that to be 0 on the other side. So we get 4x squared minus 6x plus 9 is greater than 0. So again, we can tell that our parabola, what way it's facing. So a equals 4. A is greater than 0. And so our parabola faces upwards. We can find h. So negative b all over 2a. So negative of negative 6 all over 2 times a, which is 4. So positive 6 over 8 reduces to 3/4. So we can plug it back in this one, or we can plug it in the one we just found, which I think is probably going to be easier. So k is equal to 4 times, I'm going to put parentheses wherever I see an x, and then go back in and write in 3/4. So k is equal to 4 times the quantity 3/4. That 3/4 squared minus 6 times 3/4 plus 9. So order of operations, I have 4 all times. I have to square this before I can start simplifying or multiply. So 3/4 times 3/4. 3 squared is 9, 4 squared is 16. Before we go over, let's just simplify now. So 4, so I know what my common denominator maybe have to be. So 4 goes into actually both of those. So I'm left with a 9/4. And I notice here, there's no exponent on the 3/4, so I can start simplifying. 6 is in the numerator, and I have 4 in the denominator. They both have 2 in common. So multiplying straight across, I get minus 9/2, which I'm going to need a common denominator, which is 4. So let's multiply that by 2 over 2 plus 9. This one needs to be multiplied by 4 over 4 to get the common denominator. So k is equal to 9 minus 18 plus 36. So 9 minus 18 is negative 9. Negative 9 plus 36 is 27. So 27 in the numerator, all over 4. So it makes more sense to me if I divide that in there. 4 goes in there six times, which is 24 with a remainder of 3. So it's like 6 3/4. So vertex is at 3/4 and 6 3/4. We said A was greater than 0. We just happen to get ones that are never crossing the x-axis. And so if we plotted this, and it's above the x-axis, this is asking us, when is it greater than or equal to 0? In this case, this is where everything is greater than or equal to 0. So our solution is going to be negative infinity to infinity. All x values from negative infinity to infinity. Okay, I wanted one that does actually cross the x-axis. I see one that I can tell does, so let's just pull that out real quick. So x squared plus 8x is greater than 0. So notice that this is already everything to one side of the inequality. We can find where it's crossing the x-axis, and we can find the vertex. Let's actually just find the vertex first, just because we've been doing that. So h is equal to negative b over 2a. So this is negative 8 all over 2, which is negative 4. K is equal to, plugging this in wherever I see an x, so negative 4 quantity squared plus 8 times negative 4. So negative 4 squared is 16. 8 times negative 4 is negative 32. So this is negative 16. So our vertex is negative 4, negative 16. Our A value is 1. It's greater than 0, so it faces upwards. We now see that our vertex is falling below the x-axis. Oops, that's not a point. So negative 4, negative 16. I'm just going to say this is negative 16 down here. And it's facing upwards. And so basically we can see that wherever this is going to cross, that's going to be the point where it's going to be above the x-axis for x values bigger than that x-intercept, or it's going to be above the x-axis for x values less than that x-intercept. So we got to figure out what those x-intercepts are. And so we're trying to find that at the equation y equals x squared plus 8x. Well, I chose one that was actually really easy. Set x or y equal to 0 and solve for x. Well, this factors really nicely, right? We can factor out an x, and that would give me x plus 8. So once we set the polynomial equal to 0, factor it, set each factor equal to 0. So this is when x equals 0. My graph is a little off up there. And when x is equal to -8. It's not my x-intercept. So again, we're looking at it, when is it greater than 0? So above the x-axis. So it doesn't have the equal sign. So again, you're looking at not including that value. So you're going to use a parentheses. And so our solution is going to be -infinity all the way up to -8, union, and then 0, parentheses around that, and to infinity. Okay.
Yeah, you said that by looking at that equation, you were able to tell that it was going to be below the x-axis. Is that because they didn't have a c value, so you knew there was going to be a y-intercept at 0?
I knew it was going to be below the x-axis just because of the vertex, the point. My y value is negative, and so of my vertex. So if I had had a positive y value, that vertex would be above the x-axis.
Okay.
But I didn't know it was above or below at first, just looking at the equation. But looking at the equation, I could tell that this was going to cross the x-axis because I could factor this easily and find out what value set it equal to 0.
Okay.
And so that's why I chose that one, not because of the other ones I chose. I didn't really want those to be all above or all below the x-axis, or where you're no solution or all solutions. Okay. Okay, so one other type that you guys might see are when you have a multiple equations or multiple inequalities. So for the following, you're going to be given f of x and g of x. Let me just pull one. So how about f of x is equal to -x squared plus 4, and g of x is equal to -x minus 2. And so we want to answer the following questions. We want to know when is, let's look at this, f of x equal to g of x. Okay, let's look at first graphing these. It's a good practice, and we're getting into a lot of graphing right now. We can use transformations. If I use transformation on y equals x squared for f of x, first thing that we do with transformations, there's no horizontal shift because there's no value within the x or parentheses. But so then we do reflection, and this minus sign, it's in front of the x. So it's changing my x values. So it's reflection across the y-axis, which doesn't really mean anything in our case. And this is shifted up 4. So that vertex that was here, it's going to be shifted up 4. And then we know what way it's facing too, right? Oops, I didn't want to put that there. We know what way it's facing, right? Its a value is -1, it's less than 0. Sorry, a is less than 0. It's equal to -1.
I know, I really do. Come on. I'm gonna stop.
So we can find the x-intercepts. Let me just look at f of x real quick. So f of x was equal to -x² plus 4. I'm going to rewrite it a little bit, 4 minus x², just so maybe that you see that that factors really easily. Difference of squares. So this is 2 minus x, 2 plus x. So we have x-intercepts when those values are equal to 0. So when x is equal to 2 and x equals -2. So this is our f of x value, and we want to graph g of x. Well, g of x is a linear equation, and it's in the form y equals mx plus b. So we know what the slope is, and we know what the y-intercept is. And so b is -2. And our slope is -1. So we could write it as -1 over +1. So if I go down 1, I'd go run over 1, go up 1, run over 1, up 1, run over 1. So it looks like this is going to intersect right at 2 different spots, and we need to figure out what those values are. So rewriting it, f of x, again, is -x² plus 4. We want to know when is this equal to g of x, which was the -x minus 2. So quadratic equation, we solve those by setting everything equal to 0. Let's add x² and subtract 4. So we get 0 is equal to adding x², that's just positive x² over here. We have this minus x, and then subtracting 4, I have -2 minus 4 is -6. This factors nicely. 2 numbers that multiply to -6 add to -1 are -3 and +2. So this sets, these are equal to each other when x is equal to 3 or x is equal to -2. That's just the x value. We need to figure out what the y value is. So it doesn't matter which equation you plug it back into. So if x is equal to 3, we can either plug it into our f of x, there we go, which was this one, or our g of x. It might be easier to do g of x, right? So I got g of 3. This is equal to negative, I see an x there, replace it with 3, minus 2, or -5. So this point right here, we just found was it was +3, -5. So do the same thing to figure out that value. This time we're plugging in x is equal to -2. So if we plug that into g, we get negative of -2 minus 2. So this is 2 minus 2, which actually gives us 0. So we have a point at -2, 0. So I'm just going to make it like that. It says, when is solve for f of x greater than g of x? So we're looking at, when are these y values bigger than these y values? So where would that occur on our graph? I'm asking you guys now. I feel like I'm talking too much.
-2 to +3.
Exactly. So notice that this piece of the graph, the parabola piece, is bigger than these, the linear line, those y values to there. Oops. And so it's all of the x values that are falling in between -2 and 3. I'm using interval notation. It looks like a point, but it's not. And I need those parentheses there. If it had said almost the exact same thing, but it had the equal sign there, just be careful with the notation. If that n value is included on the inequality notation, that's where you use the bracket. So -2 with that bracket on that left-hand side, (3) bracket. So looking at the picture can help. If you didn't want to graph both of those pictures, what you could have done is we could have, in this case, if I look at my f of x function, so f of x was the -x² + 4. I want to know, when is this greater than g of x, which was the -x - 2. And then we could solve here. So we could get x to one side. So if we added x² and we subtracted 4, this would be 0. It would have to be greater than x² - x - 6. This value, we just found the x-intercepts. This was +3 and -2. It's facing upwards because our a value is positive. Oops. And it wanted to know, when is 0 greater than, or when is x² - x - 6 less than 0. So that piece, this is less than 0. Between -2 and 3. It's a different picture because of how we're solving it, but we get the same answer. Okay, so that's another way you could approach it. If you didn't want to graph both of them, you could set them equal to each other and get everything to one side and then do it that way. Or in this case, not equal, use the inequality. So any questions on that? Okay, so that is the 4.5. Let me actually, before I stop, let's just go and look at those. No, it's not. We already looked at it. I was going to say, let's just go graph those on Desmos, but we actually graphed them, so we really don't need to. Stop.